This is Cambridge IGCSE paper chemistry for paper 4, 0620, paper 4, variant 2, February, March from 2019. Question number 1. Period 3 of the periodic table is shown. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Answer the following questions using only these elements. Each element may be used once, more than once, or not at all. State which element A is a gas at room temperature and pressure. That will be chlorine and also argon. B forms a basic oxide with a formula of the form X2O. So we know that basic oxides are usually metal oxides. So it will either be sodium oxide, magnesium oxide, or aluminium oxide. But the formula given here is X2O. Oxygen is a group 6 element, which means that the ion form, which is an oxide ion, carries a -2 charge. In order to form X2O, it will mean that X has to be having a +1 charge. So X must belong to group 1. So the only answer possible is sodium. In fact, the formula for sodium oxide is Na2O. C is made of atoms which have a full outer shell of electrons. That will mean that it's from group 8. So the only answer possible is argon. D forms an oxide which causes acid rain. So we know that acidic oxides are usually non-metal oxides. So the possible answer is sulfur, as we know that sulfur dioxide, sulfur trioxides, they can dissolve in water, rainwater, to form sulfuric acid. So the answer is sulfur. E is extracted from bauxite. So bauxite is actually an ore for aluminium. So the answer is aluminium. You just need to memorize this one. F forms an oxide which has a macromolecular structure. So out of the list, the only possible answer is silicon. All right, so silicon dioxide, or commonly known as silicon 4 oxide, okay, can be found in sand or in quartz. So silicon 4 oxide is quite special in terms of it has a macromolecular structure. Moving on, G consists of diatomic molecules. So when we see the word molecules, we should think of non-metals, right? So throughout the list, silicon is a semi-metal, phosphorus, sulfur, chlorine, argon. These 4 are possible, but it's given as a diatomic molecule, so means that the only possible answer is chlorine. Okay, so chlorine has a formula of Cl2, which shows that it's diatomic in nature. Moving on to number 2, A. The table gives information about some atoms or ions, A, B, and C. Complete table. So A is given that it has 11 protons, 10 electrons, and has an electronic structure of 2,8. So what's the charge? We see that there's one more proton than electrons, which will mean that it will carry a +1 charge. For B, it has 18 electrons and the charge is 0. Whenever we see a particle with charge 0, it will mean that the number of protons is equal to the number of electrons. So that will mean that it has 18 protons. For the electronic structure, it is derived from electrons. So means that it will have 2,8, 8. For C, it has 10 electrons. The electronic structure is 2,8. but it has a charge of -1. So having a -1 charge means that it will have one extra electron compared to the number of protons. So it has 10 electrons, which means that it will have 9 protons in order to create the -1 charge. All right, B1. Carbon is an element. Define the term element. So there are two possible answers here. You can say that elements are substances that cannot be broken down into two or more simpler substances by chemical means. So in the realm of chemistry, we like to think that elements cannot be broken down further. All right. Otherwise, elements, you can mention it as it is made of atoms with the same proton number. All right. So that's the another possible answer. For 2, carbon 12, carbon 13, and carbon 14 are isotopes of carbon. Complete the table. So isotopes are defined as elements, atoms of elements that carry the same number of protons but different number of neutrons. All right, in fact, you can read it from the symbol. The smaller number tells you the number of protons, that's the proton number. The larger number is actually the sum of protons and neutrons. So all of them has 6 protons. The smaller number is 6. The larger number tells you the sum of protons and neutrons, which means that in order to find the number of neutrons, all you need to do is to take the larger number minusing the smaller number. So that will be 12 minus 6, 13 minus 6, which gives you 7, and then 14 minus 6, which gives you 8. So these will be the answers for this table. Moving on to question number 3. Fluorine is a group 7 element. Fluorine forms compounds with metals and non-metals. Predict the physical state of fluorine at room temperature and pressure. So this is a knowledge-based question. Fluorine is categorized as a greenish, yellowish green gas. Okay, it's a gas at room temperature and pressure. Now B, fluorine exists as a diatomic molecule. Complete the dot and cross diagram to show the electron arrangement in a molecule of fluorine. Show outer shell electrons only. So we need to know the electron arrangement of fluorine. So due to its position, fluorine can be located in the periodic table at essentially period 2, group 7. Right. So it is 2, 7. Okay, 2, 7. And then what we have here is that it wants the outer shell electrons only. So you just need to draw 7 electrons. All right. So when it forms F2, okay, it will carry an electron arrangement of 2, 8 for each of the fluorine atoms. So it means that each of them will have to share 1 electron. They have to contribute 1 electron for sharing each, which makes the sharing part 2 electrons. Okay, a pair of electrons is shared at the center. And then you just need to fill in the rest with the non-bonding electrons. So just make sure that you have 7 electrons for each of the atoms. And then make sure that there's 1 pair of electrons getting shared at the center, in the middle of the diagram. And then each is contributed by each fluorine atom. All right. So moving on to C, write a chemical equation for the reaction between sodium and fluorine. So before we write a chemical equation, let's just identify the word equation first. Sodium is Na. Okay. Fluorine is F2, not F. Okay. Remember that fluorine is a diatomic molecule. A common mistake made by students, they thought fluorine is only F. But in real life, actually, it's F2. Okay. And then word equation wise, sodium and fluorine react with each other to form sodium fluoride. So what's the formula for sodium fluoride? Because sodium is a group 1 element, fluorine is a group 7 element, which means that it will be +1 -1 for the ion forms, which makes it a 1-to-1 ratio NaF. So the chemical equation will be Na plus F2 gives you NaF. Okay, all we need to do is translate the words into chemical symbols. Okay, that's part 1, the first mark. Part 2, you have to be able to balance it. So by observation, you see that there's 2 fluorine on the left. So you have to make this substance 2, what do you call that? The sodium fluoride to have 2 on the right-hand side. And by making sodium fluoride, okay, the number of sodium on the right 2, you have to make the sodium on the left 2 as well. Okay, make 2 of them. So this is the second mark. All right, moving on to the D, explain why chlorine does not react with aqueous sodium fluoride. First of all, sodium fluoride is an ionic compound, and chlorine is actually a halogen. It belongs to the halogen group. So this is actually a metal halide. Metal halide. So what is going on here? This reaction that we're discussing is actually a halogen displacement reaction. All right. So in order for chlorine to displace fluorine out from sodium fluoride, it has to be more reactive. And because it doesn't, means that it is less reactive than fluorine. It is unable to take over the place of fluorine in sodium fluoride. Okay, it is just simply not strong enough. So what we need to write here is that chlorine is less reactive than fluorine. Or another way is just tell me that fluorine is more reactive than chlorine, so that's why it is unable to get displaced by chlorine. Moving on to the next question. E. Tetrafluoromethane and lead-2 fluoride are fluorides of group 4 elements. Some properties of tetrafluoromethane and lead-2 fluoride are shown in the table. So we are given the properties in terms of formula, in terms of melting point, in terms of boiling point, conduction of electricity when solid, conduction of electricity when molten. All right, so let's look at number 1. What is the formula for lead-2 fluoride? So we have to know that lead-2 is Pb2 plus and fluoride is F minus. So essentially the ionic compound that is formed from these 2 ions will be having a 1-to-2 ratio. Okay, you just need to switch the numbers. And then on 2, what type of bonding is present between the atoms in tetrafluoromethane? So this substance, as you can see, it's made from carbon and fluorine. So essentially, it's composed of non-metallic elements, and then they form a compound, which means that it will be a covalent compound. So covalent compound has covalent bonding. All right. Moving on to 3, what type of structure does solid lead-2 fluoride have? So we know that this is an ionic compound, and ionic compounds are categorized by their giant structure. So you need to write down giant. All right, they're huge, ionic, and lattice. Okay, giant ionic lattice. Moving on to number 4, explain in terms of attractive forces between particles why lead-2 fluoride has a much higher melting point than tetrafluoromethane. In your answer, refer to the types of attractive forces between the particles and their relative strengths. Okay, so ionic compounds, as we mentioned, it's this substance is an ionic compound, so it has ionic bonding between the ions. For tetrafluoromethane, okay, between the atoms, like within CF4, it has covalent bonding. But this question is about particles, between the particles, between CF4 molecules. It has another kind of bonding, which is weak forces of attraction. Okay, apart from covalent bonding within the structure, in between the particles, there is also weak forces of attraction. So we have these two forces. There will be 2 marks. All right. So between the do mention the particles. So between the ions, and this one is between the molecules. Okay. And then what you need to mention is the strengths. So we see that lead-2 fluoride has a higher melting point, which means that the bonding is stronger. Okay. So ionic bonding is stronger than the forces of attraction between CF4 molecules. Ionic bonding between the ions in PbF2. Sorry that I missed that just now. Okay. So I can just mention that it simply requires more energy in order to overcome the forces of attraction. Okay, so for should be fine. It's a 3 marks question. Moving on to F. Okay, tetrafluoroethene is an unsaturated compound with the formula C2F4. Tetrafluoroethene is the monomer used to make the polymer polytetrafluoroethene. What is meant by the term unsaturated? So if you look at the structure of C2F4, okay, it's an ethene structure, which means that there will be a carbon-carbon double bond, and then there's tetrafluoro, which means that there are 4 fluorine atoms. So it looks like this. So unsaturated actually means not all the bonds in the molecule are single bonds, right? We see that there's a double bond here. Okay, so you just mentioned that not all the bonds are single bonds. All right, so moving on to 2. Describe a test to show that tetrafluoroethene is unsaturated. So the test for unsaturated organic molecules is to use bromine tests. Okay, whenever you see the word unsaturated test, you should think of bromine. Why? Because the reason is when you add an unsaturated organic molecule with bromine, bromine is categorized by its brown color, reddish brown color. So when bromine gets incorporated into the structure, okay, so what happens is that the double bond gets broken down into 2 single bonds, and then the bromine gets integrated into the structure. So when it gets integrated into the structure, this is actually colorless. So it turns from brown to colorless. So the observation will be it turns colorless, or you may say that it decolorizes. All right, so there will be 2 marks. Moving on to 3. So draw the structure of a molecule of tetrafluoroethene, which is what we did just now. Let me just copy and paste this structure. So ethene, okay, ethene is characterized by the double bond. And then the tetrafluoro tells you that there's 4 fluorine atoms, and make sure that carbon has 4 lines. Okay, 1, 2, 3, 4. Each carbon has 4 lines because it's a group 4 element. 4. Tetrafluoroethene can be polymerized to form polytetrafluoroethene. So we're doing polymerization now. Draw one repeating unit of polytetrafluoroethene. Show all of the atoms and all of the bonds. So what you need here is we are just drawing the repeating structure. So how does polymerization occur? The double bond gets broken down. It's broken down. Allow me to just move this around first. Move the fluorine atoms around. Okay. I think it will be better if I just erase them. Okay, so how does polymerization occur is when the double bonds get broken down, okay, they get broken down into 2 single bonds. So the 2 electrons found here actually moves to the opposite sides, okay, at the corner of the carbon, which provides the linkage. Okay, so that's the repeating structure. Okay, so look clearly the difference. The first one, monomer, will be having a double bond at the center. For the polymer, the repeating structure will be having 2 single bonds hanging out there, and then the double bond is reduced to a single bond. All right, so number 5, deduce the empirical formula of tetrafluoroethene. So what's empirical formula? Empirical formula is a simplified version of formula, which is in simplest whole number ratio. So the formula of tetrafluoroethene is actually C2F4, C2F4. And the simplest whole number ratio can be generated from the original ratio, which is a 2:4 ratio. So now you just need to simplify it into 1:2. So you just take the numbers and then put them underneath the atoms, the elements. So it will be CF2 instead. All right, moving on to polytetrafluoroethene. So, in fact, monomers and polymers share the same empirical formula because it's built from the monomers. So all you need to do is just copy and paste CF2. All right, so moving on to number 4. The question is about ethanoic acid, CH3COOH. Ethanoic acid is manufactured from methanol and carbon monoxide, given in the equation. The process is done at 200 degrees Celsius and 30 atmospheres pressure. The forward reaction is exothermic. Complete the table using only the words increases, decreases, or no change. On the left, you have the rate of reaction. On the right, you have equilibrium yield. And do remember that these two are different concepts. When a reaction is fast or slow, doesn't mean that the yield will be better or worse. These two are entirely different concepts. So I will like to draw a line in between so that we are clear that these two are entirely different concepts. You shouldn't get them mixed up together. So let's focus on rate first. What do we understand about increasing rates? When we add a catalyst, okay, catalysts are essentially substances that help to speed up reactions most of the time. Okay, so this one will be increases. Increasing temperature, so you are providing heat energy, the particles move faster, they collide more, so essentially they react better, they react more. So you will increase the rate of reaction. Okay, and the last one is given, decreasing the pressure will decrease the rate of reaction. Okay, whereas for equilibrium, which is a slightly difficult concept for most students to grasp. Okay, first of all, adding a catalyst won't change the yield at all. It simply increases the rate of reaction, but it doesn't affect the yield. Now, next, increasing temperature. So, increasing temperature in a reaction that is reversible. Okay, what we need to understand is that increasing temperature shifts to the equilibrium position to the endothermic reaction. Okay, increasing temperature, it will shift towards the endothermic reaction. And given in the question itself, it says that the forward reaction is exothermic. So if the forward reaction is exothermic, the reverse reaction will be endothermic. So by increasing the temperature, it shifts to the endothermic reaction. It should shift to the cold side of the reaction. Okay, so it shifts to the left instead, which means that you are producing less and less ethanoic acid. So this one will be decreases. Okay, it will depend on the nature of the reaction. Increasing temperature will will actually shift the position to the endothermic reaction instead. Next, decreasing the pressure. So what is the effect of pressure on reactions that are reversible? So what you need to know is that pressure affects reversible reactions that involve gases. So in this case, we see that all of them are gases, all of the reactants and products are gases. So on the left, you have 1 plus 1, 2 gases. On the right-hand side, it is having one gas only. So the idea is that if you decrease the pressure, it will shift to the direction which has more gases instead. So in this case, we see that the left has two gases, so it will shift to the left. Same as the previous one, which means that this will decrease the equilibrium yield of the product. Okay, so these two will ultimately depend on the type of the reaction. Now, B, how would you show that an aqueous solution of ethanoic acid is an acid without using an indicator or measuring the pH? State the reagent that you will use and give the expected observations. Write a chemical equation for the reaction that you describe. So this is an interesting question because it asks you not to use any indicators or any pH meters. So how can we prove that this particular solution is actually an acid? Okay, so all we need to do is having this simple idea that only certain substances can react with acid. Right, not everything can react with acid, only like certain specific materials. And if I'm adding this substance into acid, they both react with each other, it pretty much proves my point that this substance is an acid. So we have to ask ourselves, what are the substances that we have learned that can react with acid? So you have metals, right? Metals react with acid, and that gives you salt and hydrogen gas. You also have slight variations of the same idea, which is you can use metal carbonates, or you can also use bases. All right. So essentially you can pick either one as long as it's suitable and as long as it's not too reactive, because if you use a too reactive substance, it is not exactly safe to do it by yourself. Okay, so let's pick one that is slightly moderate. I would say, well, the easiest one is just pick a metal, for example, magnesium, which is a moderately, like, not too reactive, but just moderately reactive in terms of comparing to other metals. Okay, so let's pick magnesium metal. So what are the observations when you put magnesium strip, okay, cut a piece of magnesium strip and then you put it in to the acid? What you will see that the magnesium metal will dissolve. Okay, dissolves in the acid. Or you can just give me the answer as that there will be bubbling, there will be effervescence that occurs in the reaction, right, due to hydrogen gas being produced here. So what's the chemical equation? So we have to know that metal plus acid gives you salt and hydrogen gas. So we're using magnesium metal now, and we are using ethanoic acid. The formula is CH3COOH. That will give you the salt. Okay, so the idea is that magnesium reacts with ethanoic acid. It will form you a salt, which is known as magnesium ethanoate. Magnesium ethanoate. Essentially, ethanoic acid will form ethanoate salts. All right, so you have CH3COO minus, that's ethanoate, and then react with magnesium. And because the charge of ethanoate is -1, magnesium is a group 2 element, which makes it +2. So you will have formed 2 ethanoic ions combining with 1 magnesium ion. So that's the final formula. Okay, and hydrogen gas. And make sure you balance the equation, which is, okay, put a 2 as ethanoate part, has 2 of them on each side. And then hydrogen has 2 on each side. So that's the final equation. Let me just copy this down. And also, by the way, as you can see, why I write the formula for magnesium ethanoate like this is because I want to emphasize the position of the ethanoate ion. Okay, usually in organic chemistry, the anions are written first, like ethanoate, for example, and then only the cations. Moving on to C. Ethanoic acid is a weak acid. What is meant by the term acid? So this is something that is theoretical. Acids are proton donors. Okay, acids produce protons. So you just need to copy and paste. You don't have to mention the H plus. Okay, just say they are proton donors. Why is ethanoic acid described as weak? Which means that the capability, as we mentioned just now, the definition of acids are proton donors. Which means that the capability is weak. In other words, it only dissociates partially. Ionizes, or should I say dissociates partially. All right, so those are weak acids. Okay, the capability of it producing hydrogen ions, let's say in water, is quite weak. Moving on to D, ethanoic acid reacts with methanol to form an ester. So this is an esterification process. Formation of ester in short is called esterification. So state 2 conditions required for this reaction. So in esterification, we mentioned that you must heat it, and also you must add a catalyst. Okay, or sometimes most of the time we can just use concentrated sulfuric acid. All right, number 2, draw the structure of the ester formed when ethanoic acid reacts with methanol. Show all of the atoms and all of the bonds and name the ester. Okay, I will suggest you, if you're not too good at this part, I will suggest you to draw a sketch first. Okay, so let's draw ethanoic acid. The prefix F means that it has 2 carbon. Oic acid tells you that it has COOH functional group. So let's draw it out. So 2 C's, and then characterized by COOH. Okay, and then fill in the rest of the diagram by hydrogen atoms. Make sure each of the carbon has 4 lines. And then for methanol, the prefix met tells you that it has 1 carbon. OL tells you that it is an alcohol, which means that it has a OH group. So this will mean that carbon, okay, let's draw it out. C with OH. Okay, and then fill in the rest with hydrogen as usual. 4 lines. Make sure that each carbon atom has 4 lines. Then esterification, if you remember, it actually removes water in the process. Okay, because esterification is a type of condensation reaction. Okay, which means water will be removed. Okay, there's removal of water involved in the reaction. So you need to take out water. Okay, take out water. So it's a H2O. So you take it out and basically do the linkage. So that's your ester linkage. So this is the structure. Okay, and then you can see that the functional group here for esters is shown like clearly. Okay, I should use a highlight pen instead. Wait, give me a second. It's this one. And okay, so regarding the name of esters is always derived from the alcohol and also carboxylic acid. So the alcohol and carboxylic acids, alcohol is changed into alkyl. Carboxylic acid is changed, the suffix is changed to oic acid. Okay, so you're using methanol, which means that it will be methyl. You're using ethanoic acid, which means that it will change to ethanoate. So this compound is known as methyl ethanoate. Moving on, name an ester which is a structural isomer of the ester in D2. So we are having a methyl ethanoate. Here, there's another ester that is involved that can be a structural isomer of this ester. So you see, you just need to rearrange the carbon atoms and you will create. Let me show you how it's done. I'm moving the carbon, the CH2 group to another side. So now, as you can see, this part is the methanoid part. And on the right-hand side, you have the ethyl part. So this is another possible isomer that comes from the same number of carbon, oxygen, and hydrogen atoms. So it's ethyl methanoid. All right, moving on to the next question. Titanium is extracted from an ore called rutile. Rutile is an impure form of titanium 4 oxide, TiO2. A. Rutile is mixed with coke and heated in a furnace through which chlorine gas is passed. The product is gaseous titanium 4 chloride, TiCl4. So that's the equation. The gaseous titanium 4 chloride produced is condensed into the liquid state. The titanium 4 chloride is then separated from liquid impurities. 1. Suggest the name of the process by which liquid titanium 4 chloride could be separated from the liquid impurity. So when we see the word separating liquid from liquid mixtures, we should think of fractional distillation. There are two main points about fractional distillation. You should remember that it's separating a liquid out from a liquid mixture. The second one is that you are separating based on their difference in boiling point. All right. So, 2. Carbon monoxide, CO, is also produced in the reaction. Why should carbon monoxide not be released into the atmosphere? This is pretty much straightforward, common sense. Because it's toxic, right? Okay, because carbon monoxide is toxic, it's poisonous. Okay, you shouldn't release it in the wild. Now, B, calculate the volume of chlorine gas, Cl2, at room temperature and pressure that reacts completely with 400 grams of titanium peroxide using the following steps. Okay, let's not get overwhelmed by the information. We just focus on the question. Calculate the relative formula mass of TiO2. Okay, when you talk about relative mass, you should refer to the periodic table because the masses are given in the periodic table. So TiO2 is composed of a Ti4 plus and also 2 oxides. In other words, 2 oxygen and 1 titanium element. Okay, so you need to check on the mass of titanium and oxygen from the periodic table, which gives you titanium. Let's check titanium. The mass is 48, the larger number in the periodic table. Oxygen is 16, so times 2. So that gets you 48 plus 32, that gives you 80. And remember that relative masses don't have any units. Okay, relative masses don't have any units. Moving on to the second one, calculate the number of moles in 400 grams of TiO2. So we are converting from masses in grams to number of moles. So the formula is taking the mass in grams divided by the molar mass, which is in gram per moles. So this one will get you moles. Okay. So we just need to look at the question. We already found the molar mass of TiO2 is exactly the same as the relative mass. So what we need to do is to find number of moles of TiO2. You need to take 400 grams divided by 80, and that gives you 5. So answer is 5. All right. So determine the number of moles of Cl2 that react with 400 grams of TiO2. Always remember that in the equation, what is the necessary information given in the equation? It gives you the mole ratio. Okay, the mole ratio given in the equation, we just focus on only these two substances, Cl2 and TiO2, is given in a 1:2 ratio. Right. So Cl2 to TiO2, the mole ratio given in the equation is 1:2. And experimentally, you're using 5 moles, right? 5 moles of TiO2. Oh wait, my mistake. This one is, I accidentally switched the numbers. So you're using 5 moles of TiO2. So in other words, you get 10 because every 1 mole of TiO2 reacts with 2 moles of chlorine gas. That will make it, if you're using 5 moles of TiO2, it's going to react with 10 moles of CO2. So you will need 10 moles of CO2. Okay, next question. Calculate the volume of Cl2 that reacts with 400 grams of TiO2. Okay, so this is a gas, right? Chlorine is a gas. And we know that gases have a very special property in terms of how much volume is it occupying. Whenever you have 1 mole of gas, okay, 1 mole of any gas, we're talking about chlorine gas, fluorine gas, ethane gas. Okay, it will always occupy 24 liters. In other words, it's 24 dm cube. Okay, cubic, if I'm not mistaken, it's decimeters. Okay, so we have 400 grams of TiO2, and it's literally 10 moles of Cl2, that is from the previous question. We're using 10 moles of Cl2, which means that it will occupy 240 dm cube. Okay, if you want to show the calculation, it will be taking, how do we find volume of a gas? We take the number of moles multiplied by the molar volume, which is 24. So you get the same answer out of this calculation. Moving on to the next question. Titanium 4 chloride, TiCl4, is heated with an excess of magnesium in an atmosphere of argon. 1. Balance the chemical equation for the reaction. So we have TiCl4 and also having, wait, let me just label them with different colors so that you can see how it's done. Okay, so as you can see, there are 4 chlorine atoms on the left, which means that because you only have 2 chlorine atoms on the right, which means that you have to put a 2 in front of MgCl2. And because here it turns into 2 Mg on the right hand side, you will need to put a 2 in front of the magnesium on the left hand side. I think that pretty much is the answer. Yeah, it is the answer. Okay, moving on to the next question. Titanium 4 chloride can be reacted with sodium instead of magnesium. The reaction between titanium 4 chloride and sodium is similar to the reaction between titanium 4 chloride and magnesium. Write a chemical equation for the reaction between titanium 4 chloride and sodium. So now we're using sodium instead of magnesium. Okay, so let's just copy and paste first. This one remains unchanged, TiCl4. We now use sodium. So a similar reaction happens, which means that you are going to form titanium, pure titanium out of the reaction, and also a chloride of the metal that you're using. So you're going to form sodium chloride. So what you need to do is balance it as well. So what we have here is, right, because now your chlorine on the right only has 1, so you need to make the chlorine on the right 4, putting a 4 in front of NaCl on the right, and then you need to put a 4 in front of Na on the left. Okay, moving on. Suggest why the reaction between titanium 4 chloride and magnesium is done in an atmosphere of argon and not in air. Okay, that's the idea behind the question. So it says that you shouldn't do it in air. Why? You see, this reaction involves metals. What happens when metals get exposed to air? It gets oxidized, right? So the oxygen from the air, okay, not to say that oxygen is air, but air contains oxygen, turns into metal oxides. Okay, so we don't want that to happen. Okay, we absolutely don't want that to happen. So that's why we use argon. So you can mention either magnesium can get oxidized in air by oxygen in air, or you can just tell me that argon is inert. It is unreactive. It won't be affecting the reaction at all. Okay, so that's 3. Let's look at D. After titanium 4 chloride is heated with magnesium, the unreacted magnesium is removed by adding an excess of dilute hydrochloric acid to the mixture. The dilute hydrochloric acid also dissolves the magnesium chloride, but the dilute hydrochloric acid does not react with the titanium or dissolve it. Okay, let's focus on the first one. Give 2 observations and write a chemical equation for the reaction that occurs when dilute hydrochloric acid reacts with magnesium. So what we have here is magnesium reacts with hydrochloric acid. You should know that it's HCl, turns into, as mentioned, it's a metal with hydrochloric acid reaction. So it's going to form magnesium chloride, metal chlorides, and also hydrogen gas. So all you need to do is just balance the equation. 2 chlorine atoms on the right, which means that you need to put a 2 in front of HCl. So that makes hydrogen balance as well for both sides. So this observation actually is repeated, which is you see effervescence. As mentioned, when you put metals in the acid, you see bubbling. And then also you see that the magnesium metal dissolves. All right. So 2, name the process that is used to separate the titanium from the mixture after all the magnesium has been removed. So you are actually doing a separation. Titanium from the aqueous mixture. So what's the best method out of separating solids? Titanium metals are solids from aqueous mixture is to just do filtration, like normal filtration. Okay, so that's how you do it. Okay, using a filter funnel and then like essentially pour the solution and then you get the solids out. Okay, they get separated out from the solution. Now 3, titanium does not react with the dilute hydrochloric acid or dissolve in it. Suggest why titanium does not react with dilute hydrochloric acid. Okay, so let's compare these two first. We have metal react with HCl, turns into, well, let me just shorten this into M as of metal. You get metal chlorides and hydrogen gas. Okay, I'm not going to balance the equation because it's not necessary to do so. You see, this time you're using titanium, but it doesn't react at all. If you observe it closely, in a way, this is actually a displacement reaction, right? Metal displaces hydrogen out from hydrochloric acid. So the reason why titanium is unable to displace hydrogen out from the solution is because it's less reactive than hydrogen. So titanium is less reactive than hydrogen. All right, so that's the answer. You can also say answers like titanium is below hydrogen in the reactivity series, or you may say that another possible answer is that you can just say that maybe the metal you are using is covered by an oxide layer. Okay, so the oxide layer acts as a barrier that prevents the acid from reacting with the metal inside. That can happen as well. Okay, moving on to E. Magnesium cannot be produced by electrolysis of aqueous magnesium chloride using inert electrodes. Name the product formed at the negative electrode, which is the cathode, during the electrolysis of aqueous magnesium chloride. So remember that in electrolysis of aqueous solutions, at the cathode, there's only 2 possibilities. Either you get metal, or you're going to get hydrogen gas. So since you're not getting the metal, okay, you're not getting the metal, So the only possible answer is hydrogen gas. Okay. The reason why magnesium is unable to get electrolyzed by the setup is because magnesium is simply too reactive. It's way more reactive than hydrogen, which means that it's not easily to be taken out. It's quite stubborn. Okay, so in order to isolate out, in order to discharge magnesium out from the solution, okay, the only way is to do it melted. Okay, you must melt magnesium chloride to molten state and carry out electrolysis. Okay, so stubborn metals, I like to call them stubborn, okay, reactive metals, you have to melt the ionic compound in order to electrolyze, in order to isolate out the metal out from the solution, okay, out from the ionic compound. Now, moving on to the next one, number 6. This question is about transition elements. Transition elements are harder and stronger than group 1 elements. Describe 2 other differences in physical properties between transition elements and group 1 elements. So what we see here is that you're comparing transition metals. Transition elements are also known as transition metals, and group 1 elements, which are also metals. They are known as alkali metals. We cannot use this answer, obviously, because it's given already. So what we can do here is, well, we first, physical properties can involve like melting point, boiling point, right? So transition elements are categorized by like way higher boiling point or melting point than group 1 elements. So you can mention that it has a higher melting point, or you may say boiling point, compared to group 1 elements. All right. Second, you may also mention that physical properties, you can also mention about density, right? Because if you have done it in the school lab, essentially sodium metals, lithium metals are quite light compared to, well, the same volume of let's say copper wires. It's heavier. Okay, if you have used a copper, if you have like touch or carry a copper electrode, you realize that it's quite heavy. It's not as light as in metals, like group 1 metals. So it has a higher density compared to essentially group 1 elements. Okay, so state another physical property of transition elements that is similar to group 1 elements. So we know that they also conduct heat and electricity, but no difference in terms of that. Right, so both of them conducts electricity, or should I mention, okay, let me rephrase this by, they are good conductors of electricity or heat. You may also mention that they are malleable. You may also mention that they are ductile. Okay, let's look at C. State 2 chemical properties of transition elements. So this special is unique to transition elements. That's why we give them their names as transition elements, because they keep on changing in terms of oxidation states. Okay, so you may mention variable oxidation state. Okay, other than that, they also keep on changing their colors. Okay, they form colored ions, or you may say colored compounds. Okay, unlike group 1 elements, which are quite boring, they are silvery gray or colorless in solutions. Let's say I give you an example, like transition elements, think of iron. Iron, you can find them mostly in 2+ or 3+. Okay, the oxidation number is +2 or +3. So iron 2 usually is green in color most of the time. And then iron 3, most of the time they are brown. Okay, like rust, for example, rust is reddish brown. Okay, rust is due to iron 3, the presence of iron 3 actually. Okay, so you see that they keep on changing their colors. They also keep on changing their oxidation number. You may also mention that they act as catalysts. Okay, like for example, in contact process or Hilbert process, you're using transient elements. Okay, you must transient elements are used in these two reactions in order to speed up the processes. Okay, so these are unique properties to transient elements. Let's look at D. Cobalt is a transition element. Anhydrous cobalt 2 chloride is used to test for water. Okay, anhydrous means that there's no water. An means no. Hydrous means water. Okay, so without water. So we know that dry cobalt 2 chloride is blue. And when it reacts with water, when water is added, it will turn pink. Okay, so you can see this is also another special property of transient elements. Okay, which is change in color. Now, iron is a transition element. Which two substances react with iron to form rust? So in order for rust to form, it's quite common knowledge. All you need is water and oxygen. And which metal is used to galvanize iron? That will be zinc. Okay, nothing too fancy. It's all memorization of the concepts. Okay, so next F. The hull of a ship is made from steel, mainly iron. Metal blocks are placed on the ship's hull to prevent rusting. Use your knowledge of the reactivity series to explain why magnesium is suitable to use as the metal blocks, whereas copper is not suitable to use as the metal blocks. So let's understand the point of this setup first. Metal blocks in surrounding the hull of the ship is to act as a barrier. Okay, they are barriers, okay, to prevent water or dissolved oxygen to get into the steel, okay, of the irons of the ship's hull. So they are barriers. In other words, they are protection. Okay, this is known as sacrificial protection. Okay, because the metal blocks sacrifice themselves, and then in that process they protect the ship's hull. Okay, so magnesium is suitable to be used as a metal blocks because it is reactive. Okay, it is reactive. It's more reactive than steel, or you may say iron. Okay, it's very willing to take the water, taking the water or oxygen, like try to protect the iron from rusting. Okay, on the other side, copper is simply not reactive enough. It is less reactive than steel or iron. Okay, so there's 2 marks for both. Moving on to the last question of the paper. Rust contains iron 3 oxide. Phosphoric acid H3PO4 can be used to remove rust from an iron object and prevent further rusting. 1. Write a chemical equation for the reaction between iron 3 oxide and phosphoric acid to form iron 3 phosphate and water. So we write down the formula one by one first in order to not overwhelm ourselves. So iron 3 oxide is Fe2O3. Phosphoric acid is given, it's H3PO4. Iron 3 phosphate is FePO4 because iron 3 carries 3 plus. And then phosphoric acid, the phosphate carries 3 minus. So they will neutralize each other, which forms a 1-to-1 ratio, Fe and PO4. Then water is H2O. All we need to do is write down the equation. And then next is just balancing. What we see here is that there's 2 iron on the left. So we need to put a 2 in front of FePO4 on the right. And we see that because there's 2 PO4 3 minus on the right hand side, so you need to put a 2 in front of H3PO4 on the left. And then next, observe that H and O, there's 6 H atoms on the left, 3 O atoms on the right, which makes it 3 sets of water on the right. Okay, last question. Iron 3 phosphate is an insoluble salt. Suggest how the formation of iron 3 phosphate prevents further rusting. So what we do here is that when we have a layer of iron 3 phosphate after we add the phosphoric acid on the rust, right? As mentioned just now, very similar to the concept that we have explored just now, it acts as a barrier from the water and also oxygen that comes from outside, okay, from the surrounding. So it acts as a barrier and prevents oxygen or water from getting into contact with the iron beneath. So prevents iron from getting into contact with water and oxygen. Okay, so that's pretty much all of this paper.